Hi everyone. So in this video, we're going to work through a Year 12 mechanics question from the AS sample paper. And this question is about a velocity time graph and also some SUVAT equations. Now, the initial introduction to the question says, unless otherwise indicated, whenever a numerical value of g is required, take g equals 9.8 meters per second squared. So in all of these mechanics questions, you will always use g equals 9.8 unless they say to you that g is 10, for example, or they give you some other value to use instead. Okay, so let's go and read the rest of the question. So a car moves along a straight horizontal road. At time t equals 0, the velocity of the car is u, so you can see that in the graph on the page there. The car then accelerates with a constant acceleration of a meters per second squared for t seconds. So we have a journey of t seconds up to there, and the acceleration is a. So remember that when you have a velocity time graph, the gradient is the acceleration. So that's probably going to come in handy in this question. The car travels a distance of d meters during these t seconds. So also with a velocity time graph, remember that the area between the curve or line, curve slash line, and the t-axis, the time axis, is the displacement. So we'll keep that in mind. In this case, the displacement will be the same as the distance traveled because, as you can see in the diagram, the velocity is always positive, which means you're always moving forwards along the road. So the distance traveled in this case is just the same as the displacement. Okay, so again, the distance traveled is d meters for these t seconds. Figure 1 shows the velocity time graph for the motion of the car. Using the graph, show that d is equal to ut plus a half at squared. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level Maths topics that will come up in your 2027 exams. So now that the 2026 exams have finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018 and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up. Sign up to the app and you'll be able to access all of these 2027 predictions. Now, if you do know your SUVAT equations, you will recognize this because it's basically the SUVAT equation from your formula book, S equals UT plus a half AT squared. So basically in this question, we have to use the graph to essentially prove that formula. And as you will see in the brackets that they've written in the last kind of paragraph, no credit will be given for answers which use any of the SUVAT formulae in the formula book. So we have to use the graph to do the question, right? So as we said, the distance traveled in this case will be the area of, well, the area under the graph, I should say. So in this case, it's the area of the trapezium, because obviously that shape in the graph that we've created is a trapezium. So the formula is, of course, a half of a plus b times by the height. So then what we can do now is we can say that this is equal to a half. And then the a, I mean, we can call the a here this length from 0 meters per second up to u meters per second on the speed axis or the velocity axis. We can call this height there the b, and then the height, the actual height from the formula for the area of a trapezium would be this length there, so t. So what we have then is half of u, because that's the a. Now, to be honest, there is an acceleration of a in the question. So what I'm going to do, I'm going to put like a little squiggle on the top just to make it clear that this is not the acceleration to the examiner. So this a squiggle is u, capital U. And then we have this b, which we don't know just quite yet, but we'll come to work that out. And then the h in the formula is going to be t, capital T. Perfect. So we now need to find the b. How can we find the b? Well, again, we know that the gradient of a velocity time graph is the acceleration. So we can make use of that. So we can say that also the acceleration is gradient of graph, and that is equal to change in velocity over change in time. Now we know what the change in time is. We know the change in time is just capital T. So change in velocity over capital T equals A. So therefore that means change in velocity is equal to A times capital T. Now the change in velocity on our diagram is basically the length from there up to there. So from a speed of capital U up to this final speed there. So that would be the change in velocity. Just another quick interjection. If you are currently doing Edexcel A-level Maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. So that means that the B, so therefore this B from the area of a trapezium formula, is going to be U plus change in V. So in other words, it's going to be U plus AT. So again, that distance there is capital U. This distance there is a capital T, as we just worked out. So we can now say that U, or B, sorry, is equal to capital U plus A and then T. There we go. So now then, what we can say is that the distance is equal to a half and then times by U plus B, but we know that B is now going to be U plus a T and then times by the T at the end. So this is a half of 2U plus a T times by the T. So therefore, this is going to be, when we expand the brackets, this is going to be just 1U plus a half a T multiplied by the T at the end there. And we're almost there. Just multiplied by the T again. UT plus a half AT squared as required. Perfect. So we've got our formula. We've proved our formula there by using the graph that they have given us. Now, if you do have any questions, do feel free to drop a comment below. But hopefully that question did make sense.